Okay, I'm going to look at a lighthouse problem. And this is a good example of what happens when you have a rotation matched with a linear projection. So we have a lighthouse. This is 47 in the book. There's a lighthouse. One kilometer offshore. And its beam rotates at a constant rate of 3 revolutions per minute. For people in radians, one way around is 2 pi, so this is 6 pi rotations per minute. And so what we want to know is how quickly does the rate move down the shoreline when the image is a kilometer away. So let's see here. So let's get a little bit of the drawing here. So how fast is the image moving? One kilometer down the shore. So let's get our shoreline here. You know what, I'll be all beachy. I'll make it yellow. There's our shoreline. Put our lighthouse out here. And then it's got a bright light. And what we're asking ourselves is, as this rotates, how fast is that image moving? And let's see. We'll keep this. We'll make this the y-axis, and this the x-axis, I guess. We'll make this positive. All our directions positive, and so this has a rotation where it's rotating at 6 pi per minute. And we want to find out what dy dt is. So what we want to do is look at any relationship we can have here angle-wise. So this 1 kilometer is fixed. So when it's here, it's 1 kilometer, and it's going to grow in a tangent relationship. So y is tangent theta, which is opposite over adjacent. So tangent theta opposite over adjacent, and the adjacent is 1 kilometer. So opposite over adjacent. Let's do our definition of our tangent function here. So tangent of theta is the opposite over adjacent. And so we want to solve for the opposite. So the opposite is equal to the adjacent times the tangent of theta. And the opposite is y, and the adjacent is always 1. So tangent theta. So dy dt is equal to secant squared theta d theta dt. And we just need to know what the angle is once it's fully extended. And so this is a 1, 1, 1. So that's a 45-degree triangle, or a pi over 4. And so what was d theta dt? It was 6 pi per minute. And so dy dt is going to turn into 6 pi kilometers per minute. Right? Because pi over 4... oh, wait, it's the secant of pi over 4. I was doing the tangent. Let's see, what is the secant? Secant is 1 over cosine. Pi over 4. Cosine pi over 4 is 2 over root 2. So this is 2 over root 2 squared times 6 pi per minute. Which, let's see, 4 over 2 or 2. So it's not 6 pi per minute, it's 12 pi kilometers per minute. And this is another related rate where we're translating from one geometrical change to another.